Hey everyone, it's me, Miss B, and in this video we're looking at the Unit 2 Lesson 1 Cumulative Practice Problems for Illustrative Math Geometry. So looking at our first piece here, we have a statement. When rectangle ABCD is reflected across line EF, so reflected, the whole thing's reflected across this, the image is then DCBA. How do you know then that segment AB is congruent to segment DC? So this isn't asking how we know the rectangle is congruent to its image. It's how we know that the two segments are congruent to each other. Because we know the two segments are, the two rectangles are congruent to each other, we can say we know the two segments are congruent because of choice D right down here. Corresponding parts of congruent figures are congruent. So you'll see this as CPCF. C abbreviated. Sometimes you'll see CPCTC or even CPCPC for polygons or something like that. But they mean the same thing. Corresponding parts of congruent shapes, images, figures, triangles are congruent. So question 2 here, we have a triangle FGH. So FGH is the bottom triangle here. It's the image of isosceles triangle FEH reflected across line HF. So we want to select all statements that are true as a result of corresponding parts of congruent triangles being congruent. So the first thing I'm going to do is actually mark my congruences on my shape here. So if EF is reflected across, it's going to become FG, and I know that FG should then be congruent to it. It's a corresponding part, and that also means the same as this side over here. So what else we can say, that actually gives us the first option here, not A, but our first correct answer of B, which is that EFGH has 4 congruent sides. So those 4 sides are congruent. Now we also have that a couple other things here we're going to look at. So it says diagonal FH. So they're saying diagonal FH, that's the diagonal of the quadrilateral, meaning it goes from one corner to the opposite corner. The other diagonal would be EG. They're saying FH bisects angles EFG and EHG. So if we have a 3-letter name, I start at that letter and trace out those 3 letters. That means the angle it's referring to is here for EFG. For EHG, I follow E to H to G, and then this is the angle created by that. So it says that it bisects those angles, and because it's a reflection, this is actually going to be true. We don't necessarily know that those 2 angles are going to be congruent to each other within the triangle, but because they're reflected across, they are. So those 2 angles actually, they will be congruent to each other. But we haven't found, we're not proving that yet in this class. So at least for our purposes, we know something reflected across is congruent, which means the big angle here is cut into 2 equal parts, which means it's bisected. So part C, or option C, is actually correct. And then what else do we have? They say diagonal FH is perpendicular to side FE. Well, side FE is right here, and we do not know that this is perpendicular, so that's not one of our answers, or not one we're going to choose at least. And then they said angle FEH is congruent to angle FGH, and that is also going to be true. I'm going to put 3 lines on this one, because E, when reflected across, is going to land at G, so we know that angle needs to be congruent to the one across. So yes, this one works also. So B, C, and E are all correct. Okay, so flipping our page, moving on to question 3, we have some instructions. We're supposed to reflect right triangle ABC across line BC, so right here, and then classify the triangle according to the side lengths and say how we know. Well, I need to reflect across, which means I'm going to basically be reflecting across this line right here. Essentially, that's going to create a congruent shape on the other side of about this large. Now, I didn't do that, obviously, using any sort of construction techniques, but you can also just draw this with your pencil. So what is going to be congruent to what? Well, I know that this side here should be congruent to this one. I also know that this little piece should be congruent to this. I'm going to have angles that should be congruent to each other and top side angles that should be congruent to each other. So it said classify ACA prime according to its lengths. Well, this is A prime because that's the image of A. So ACA prime has two sides that are the same length, which means it is going to be isosceles. So it is isosceles. Question 4. We have triangles FAD. So when they're describing FAD, I'm actually going to highlight inside of these so you can see them. FAD is this one right here. So that's my yellow triangle. And DCE, so DCE, my green triangle, those are translations of ABC. So this one here, which means we just slid them in a certain direction. So we want to select all statements that must be true. So in that case, we're going to have a couple different things here. Now, we know that points A, B, and F are going to be collinear. We know this because A, B, and F are right here. And it looks as if we are translating this shape so that B then coincides with A, which means we're translating in that same direction. And a translation is either going to take a line to a parallel line or to itself. So in this case, since it is traveling along itself for the translation, if we created this into one whole big line, that means that A and F have to be on that line as well. So I'm going to put a little note next to this and just say translations take lines to parallel lines or themselves as my little note of why. And I'm going to use the two vertical lines to mean parallel or itself. And in this case, it's taking it to itself because it is translating along its own line. Okay, let's look at option B. B says the measure of angle BCA, so that's BCA. So this angle of my blue triangle is the same as the measure of angle CED. Yes, that's true also because translation is going to preserve that angle measure, and those are corresponding pieces of these triangles. Okay, let's look at option C. Option C says line AD is parallel to line BC. So AD is this one here at the bottom of my yellow triangle, and that is parallel to BC, which is here at the base of my blue one. And again, because we said originally this translation took the blue triangle upward along BA, it's just a translation. And for that same reason, translations take lines to parallel lines or itself. That also works for this one. So AD is going to be parallel because BC, when translated, becomes AD. And it has to either be parallel or itself. In this case, it's parallel. Okay, option D says the measure of CED is the same as the measure of FAD. So CED, and that says it's the same as FAD. So that's this angle here on the left on this triangle and on the right on this one. That is not going to be true because they are not corresponding. And we only did a translation, so they should still be on that same side. So not correct for this one. Option E says the measure of angle DAC is the measure of angle BCA. So DAC is the measure of BCA. And that is also true based on parallels. Even though that white triangle isn't considered one of the triangles I translated, those two angles, we know those lines are parallel. We just said that in the last one. These are actually alternate interior angles with each other if we think about that diagonal between them as the transversal. So this is true as well. And then option F, they said ADC is a reflection of triangle FAD. And that is not correct, because a reflection would look more like this. And you would create perpendicular, it would be the perpendicular bisector of the segment between those points. That's actually a 180-degree rotation. So we can say it's a rotation by 180 degrees. So that's why that's not true. Okay, so moving on, question 5 is actually on the next page. So we're looking at 3 triangles here. We have triangle ABC congruent to triangles BAD and CEA. So order is important, which means ABC. I'm going to highlight these triangles inside so that I know which ones are which. That is my blue triangle. Okay, green triangle I'm going to say is BAD. That is this triangle here. We're going to color this in just so I can see it better. And then CEA, that is this one right here. Okay, so these 3 triangles, they're congruent. I need to explain why certain points are collinear. So D, A, and E. Those are these 3 points right up here. I want to explain why they form a line. I can actually do that using congruent pieces here. So BAD, that angle, this one right here, that's going to correspond to ABC. So that's going to be the same as this angle down here at the bottom left. So we're just using the triangle names in order to refer to angles. At least for those 2. We're going to say another pair of angles is congruent. That's actually going to be angles CAE and angle ACB. I was like, what is the third letter there? These ones right here. So because the triangles are congruent, we know those correspond, which means a triangle adds up to 180. So all 3 of those angles there should add up to 180 degrees because these 2 angles at the top are the same as angles that are actually inside my original triangle here. So let's write this in a smaller print because it's kind of a long explanation. But we can say angle, and we said BAD is congruent to angle ABC, and we said angle CAE is congruent to angle ACB. Meaning those, well, not meaning those, how do I say this? We can just say, so the sum of the 3 angles at vertex A are or is the sum of the 3 angles is, sum is singular, is 180 degrees. So it is a straight line. There we go. So it's a straight line. Bit of an explanation, but important to understand why. So for part B, we then want to explain why DE is parallel to BC. So that is this line up here at the top. Whoops. Well, it's not going to let me draw it nicely. This line at the top and this line here across the bottom. That's easy enough because I had two sets of angles here, and I can consider like AC to be a transversal and these two to be my parallel lines. I know they're parallel because I already have alternate interior angles that are going to be congruent since they correspond. So I would say that angle, and this was CAE, and angle ACB are congruent and alternate interior angles. Therefore, DE, you're saying line DE is formally what we were calling it, is parallel to BC. And that's just the shorthand notation for it. Technically, if we're talking about a line, I should put little arrows on the end of it saying that the lines go forever, but the segments are also parallel to each other. So there we go. For question 6, we're almost done. I think there's only 7 questions on this assignment, or maybe there's just 6. But for question 6, I have the bell ringing, so I'm going to make this fast because my class is supposed to come in for 4th period. So we're trying to identify a figure that is the result of a rigid transformation of A, B, C, D. So let's highlight A, B, C, D here. I like to use green. And then we're going to describe a transformation that would actually put it on that shape. So I can be a little bit cheesy. And since I just highlighted this, now if you had patty paper, you could do that. I can actually see, well, none of these are in the right direction. I'm going to actually put some outlines on it. And that way I can change the way this looks. Nope, that's not supposed to be a curved line. There, and there, and there. So now I'll be able to actually take my shape here and rotate it. Let's rotate it 180. Does this actually line up here? Oh, it looks like it lines up here. And so a 180-degree rotation, it looks like I can do that around point B because this point was originally point B. So let's describe that. So let's identify a figure that was, now if it's A, B, C, D, that means it's going to be H or F, B, H, G. And this would be rotate 180 degrees around point B. A bunch of these other figures would work. You could actually say that almost all of them are, except for like this one here, but this one here should work as well. You could also rotate around point B. You would just swing it up this way, and I believe that would make a 90-degree angle, something similar. But I believe that's the end, yep, because my next page is lesson 2. So thank you for joining me. This has been Unit 2, Lesson 1, Cumulative Practice Problems for Illustrative Math Geometry.